So in the spirit of continuing to use Twitch to basically quickly come up with stuff that then I can refine into blog posts, I want to talk about sort of my personal manifesto, what quality coding is about. And to do that, we're going to have to talk. It's not going to be any live coding today. No code, just stories. Stories from days of old, of when I was a young warthog. And I'm recording this so that I can then turn it into a proper manifesto on my blog, on my website. Excuse me. And so feel free to pop in on the chat. That's part of the fun of doing this. But basically, when I think back on my coding career, when I first graduated from college, I didn't know anything. I had a bachelor's in computer science. I didn't know anything. I went to work for a local shop, but I wasn't working on their product at first. I was working on tools for the business end of their product, for their internal use. So it was pretty much just me coding by myself for folks. That's how it worked for the first several years of my professional career. And then went to Japan and for about 3 years, and where my primary role was to teach. After a while, I got the itch to go back to school to get a master's, because there was this thing called object-oriented programming I was very curious about. I just couldn't grasp it from reading articles from what? There was no internet. Reading articles from magazines, and so it was just stray articles. And that's all I got. So I went back to, came back to the US to get my master's in computer science, and took some interesting courses from some interesting people. If I'd known now what interesting people those were, I would have gone and done my master's probably under a different professor, because I was here. Let me get a book. I was at the University of Illinois, where Ralph Johnson, I took a class from Ralph Johnson on object-oriented programming, which used Smalltalk. I had no idea. Why didn't I do my, why didn't I attach myself to Professor Johnson? I have no idea. I just didn't know. I just picked a professor who would take me. Anyway, it worked out. So, of course, this book didn't exist when I was in school. Not, of course, just to give you a little context that I wasn't a complete idiot. This book didn't exist when I was in school. Some of the courses I took were about object-oriented programming. There was a course on software engineering that was interesting, because I got my first glimpse into this thing called iterative programming. It was a new idea. All sorts of different models, the spiral model and so forth. And so that was sort of a little peek into software engineering in my master's program. And what else did I take that was really interesting? Consequential. It'll come to me. I finished up my master's. I went to work a little more, but in a very tiny local shop. And so there was no rigor to the coding. That I really still hadn't been exposed to serious sort of, you might say, industrial level code. Oh, not a course. I was exposed to revision control. Maybe that was even earlier. That might have been at Purdue instead of the U of I. Professor Tishy. He made RCS, Revision Control System. I'm gonna have to look him up. So revision control was part of my background. I wound up moving to San Jose. For those who are just joining, I am not live coding. I'm doing a little storytelling. I want to tell a little bit about my background so that you know more about why I'm passionate about the things I'm passionate about. And feel free to jump in if you have questions or comments. So I moved out here to San Jose, which is where I still am. I thought it would be just for a brief time and then back to Japan, but here I am. And I went to work for the first time at a software company. I had no idea quite what to expect, so I wasn't shocked. Now, looking back on it, I'm horrified at some of our practices. One of those was this thing called the mountain chart. Whoop, touch that. The mountain chart. This was the chart of bugs. Basically, the way it would start, a project would start having just released, and there would still be a stack of bugs in a project that was released. Like acknowledged known bugs, defects. And then we'd start coding. And as we coded, the bugs would increase. We kept writing bugs until finally it's like, okay, we're done writing. Now we better start fixing. And then we stop writing bugs so much and we start trying to pound this mountain, the mountain chart, back down to this giant bell curve and lower it until finally it was be like, okay, that's good enough to release, even though it still has defects. Can you believe it? It sounds incredible today to think that this is how a major company owned by an even bigger company here in San Jose or in Silicon Valley operated. That was the mindset of bugs. Was it's going to be a mountain, it's going to go up, and then we'll pound it down. If you think about it, like that's a symptom of going for a long time without addressing issues, right? Because bugs happen. We just try to get them back down right away and stay at zero? What an idea. It was inconceivable back in those days. So what happened next? I got laid off. Steve Jobs came back and got rid of my whole company. And I went to work for a different company. And there I got to work on a piece of software that was used internally. So it was an internal framework used by everyone else at that company. And our job was to deliver features basically to the internal product team so that they could ship their code on both Mac and Windows with a common UI. There were parts of it that worked, and there were parts of it that we were scared to touch. We were terrified of certain areas of the code because nobody on the team had written the original code. It was inherited. Like, it was actually spun up as like a skunkworks side project by somebody inside the company saying, here, and then it became a thing. We became the team to run it. How it went. And there were no unit tests. There were no unit tests. Still, we managed to get stuff done, but like I said, there were parts of it that we were frightened to touch. Scared. So, and it got worse, right? As the longer we developed it, the creakier it got, the more fragile it became. I started to wish for solutions at this time. This is nuts. There's got to be a better way. And this book came out. Yeah. And this helped. It gave a sort of language to some things. It clarified some things that we should do and some things that we shouldn't do, and ways that we, especially with object-oriented code, that we had designed things poorly by overusing inheritance and not favoring composition, as this book teaches. So this gave me the itch. I'm like, I want to learn more about this. Where can I learn more about this? And then, by then, there was this internet thing. So I started to explore, where can I learn more about design patterns? This led me to the very first wiki, like the first wiki, which was designed as an experiment to let people update whatever they wanted to, right? That was the idea. And there were basically a few strong sections in the wiki. One was about the wiki itself and how wiki culture works, and exploring that and trying to figure out, what do we do with this tool? Another part of it was about ongoing discussions about patterns and pattern languages, because this wasn't supposed to be the Bible. This was supposed to be a template for making more patterns. Heck, there were conferences on this to continue to discuss and develop new patterns, and only a few people kind of speak in this language anymore. But cool stuff. That was one section of the wiki. Then there was this other section. This other section intrigued me. It was about a thing called extreme programming. Raise your hand if you're an extreme, if you have any background or are a fan in any way of extreme programming. For those who are just joining, I am not coding today. I'm sort of rambling a story of my history as a developer, so that you understand better what my passions are, mainly so that I can record this and turn it into a proper blog post, probably a video, where I'll do this in 10 minutes rather than rambling on for however long I'm going to ramble on. And so I went to this site and got exposed to extreme programming. It's weird voodoo, but some of it looked familiar. Some of it looked familiar to me in terms of the iterative idea that I was taught in my software engineering class, which was just like one class out of computer science. Like, whatever, software engineering, computer science is where it is. No, it's not. At least not for me. If it is for you, fully for you. Keep going, making cool stuff. But extreme programming. And there were various cool ideas which involved taking an idea that worked and saying, what if we take it to the extreme? What would it look like? For example, what if instead of doing code review, where I code, and then I probably commit it straight to the repository and then get a review. Maybe I went in many companies where code just wasn't reviewed at all. But code review as a tool for making code that works and code that works well and is designed well to be extensible. Well, what happens if we don't separate the coding from the review? What if we do both at the same time? And we turn the extreme dial up to all the way. Well, that's pair programming. What else is there? Other practices from extreme programming. What are they? Come on, help me out. Oh, time for another book. I got to go to a local conference in San Jose hosted by Dr. Dobbs. It was called Software Development. Dr. Dobbs was a great magazine because it was a quirky title for, like, Dr. Dobbs, what was it called? Dr. Dobbs. Gosh, now I'm spacing out on the full, long, sort of old-fashioned title of the magazine, but it was about programming practices. And there was a conference in town. I got support from my company to go. I went. I got this. And this blew my mind. This was, I guess, I had no idea who Martin Fowler was, but there he was, plugging his book. I got this, and I'm like, holy crap. This is what we need, We're dealing with a steaming pile of legacy code. So what do? Like how, and it's bogging us down. It's making further development slower. How do we reverse this? Well, we take the existing code and we improve the design. I showed this to my boss and he's like, get a copy for everybody. Like, everybody ought to have this. He immediately recognized that this was important. Just one problem. Step one is to write unit tests. Step one of refactoring is writing unit tests. But refactoring is a practice that comes from extreme programming. And it's kind of curious that it's the first one that this is the first book that I really dug my teeth into. To tell you the truth, sorry, Kent Beck, I still haven't read Kent's book on TDD. It's on my list. I'm sure I'll learn stuff from it, even though I've been doing TDD a while. I know I'm going to learn from it. It's not where I started. I happen to start here. This was my gateway drug into extreme programming and the things related to it. By the way, Volume 2, Edition 2, second edition. Golly, this is good. It's still good after all these years. This was good for a long time, and now, boom, check it, get it out. So refactoring is one of the extreme programming practices. Oh yeah, hey Ted. It is also a practice that is people say they're doing, but they're not. What are people doing? They call it refactoring. I think it's an excuse to rewrite code, or it's saying I'm going to fix things up, but I don't actually have tests for it. So, as Jitter Ted knows well, you've got to lay a foundation, some sort of safety net before you can leap. So, refactoring became sort of my first thing, but then I was troubled by, oh no, in order to do that, I need unit tests. So I had to learn how to write Unit tests, I had to really dig into them. Oh, yeah. You know, it's funny, Ted, that it's still... I usually keep it within reach. Like, for the longest time, it was literally within reach. Now it's just over there a short ways, but I had to, it's like, whoa, I need the recipe for this refactoring. So refactoring is an extreme programming practice, but I think it's gotten lost. Unit testing is definitely part of that. That was all part of the stuff that I learned from the wiki. And test-driven development, where it's like, what happens if we flip the process on its head, and instead of writing code and then testing it, what if we make it testable and declare the expectations up front? How does that change how we code? Other extreme programming practices, continuous integration. It's like the only one that took off. The only one that took off. Because a funny thing happened is that this thing called Agile came along. And it was basically like a truce, a confederation of somewhat similar ideas that around how to code, how to ship software, how to ship code, and how to work together to get that done. And they came together. This group of men came together and came up with the Agile Manifesto, which has been very helpful. I think it's still helpful. But somewhere along the way, the coding part got lost. The aspects of it that depend on things like refactoring were sort of like hand waved away. Scrum became the big hot thing. Hey, thanks for dropping in. Nothing new for you, Ted. You know all this stuff, but thanks for saying hi. I appreciate it. For those other small number of folks who are watching, no live coding today. I am telling a story of where my coding has come from so that you understand my passions, and so that I can turn those passions into some sort of manifesto. I thought I'd just talk about it before I blogged it in some way. So I had been exposed to extreme programming, but this other sort of thing came along called Agile, and Agile was like, okay, these are good ideas, but the reigning king of Agile was Scrum. And I'm not sure why, but Scrum, business folks started to buy into Scrum. And that's not bad. This is not bad. This is a good thing. The problem is that Scrum, by definition, leaves out the technical programming practices. Like it says, yeah, here's a way to meet, here's a way to plan, here's a way to sort of manage your work, here's a way to continue to ship, and it's like we assume that you're doing all the technical things required to do that. I think it was a real, well, I don't want to be a Scrum hater, right? It's like the Scrum folks decided they didn't need to talk about technical stuff. That's okay. That was their decision. But Scrum took off. Scrum took off in a big way. And as a result, the technical things that make iterative shipping possible have gotten lost. And that's why it's my passion, because of where I came from and the real dysfunctional ways I learned of shipping code. I'm just catching up on the chat here. 12 steps. Yeah, in a way, it's like I've never gone through the 12 steps. I'm only like familiar probably with step 1. Admit you have a problem, right? Am I getting that right? Also, you need a higher power, but that's another thing. But yeah, it is admitting that you have a problem. And I think I have seen colleagues here in Silicon Valley say, oh my gosh, Agile is the worst, like it's terrible. And I'm like, why? Why? What's wrong with it? How is it? What's your experience? And so my friend would tell me, well, gosh, now we have to like ship stuff every 2 weeks. And I'm like, yeah. And hopefully things are better for him now. But at the time, it sounded like basically it was just like, we're going to ship every 2 weeks. And here are the rules. And here are the meetings. And he was like, oh my gosh, so many meetings. And we have to do all this stuff. And it was like, instead of evening out things into a steady quality delivery, instead it was like, let's take pressure and ramp it up 100% and keep you at full pressure of intensity all the time. And he hated it. And I think the reason he hated it is because it was all the trappings. It was all the kind of the business side of things without the support needed from the code. There is absolutely nothing wrong with agility, and I'm excited to see Agile break out into other domains. I've got here my green screen is doing terrible things to this. My modern Agile coaster here. Make people awesome. Experiment and learn rapidly. The green part you can't see says deliver value continuously and make safety a prerequisite. These really good ideas from modern Agile are revolutionizing. I hope they're revolutionizing how people work in general, no matter what their domain. But think of this. If we're in a practice like medicine, I've got family members in medicine and in medicine education, so I know a little about how seriously they take their practice and the improvement, the continually improving how they do things. You would not say that Scrum is the way you're going to fix a hospital, for example, and assume, actually you might say that because you would assume that they wouldn't stop doing medicine that was effective at fitting into a system of feedback. You would count on it. You would depend on it. But Scrum in programming, without the agile practices, the technical agile practices to back it up, would be like saying, I'm going to fix this hospital system, but I know nothing about medicine, and I don't care to learn about medicine, and don't bother me with the details of medicine. Those are all irrelevant. No, they're not irrelevant. They become even more relevant and probably require some changes in how you practice and measure and get feedback and improve how you do medicine. That's my analogy, because I feel like with Scrum in particular, by choosing not to incorporate anything technical into the Scrum book, the official Scrum guide, they chopped out the feet of the software industry and led to dysfunctions that lead to people like my friend saying, oh my gosh, I hate Agile with a passion. Not good. And not hard to fix, because then I think that's when this term technical Agile started to come around. It's like, what is that? Well, those are the other parts. It's extreme programming. Those are refactoring. Those are unit testing, test-driven development, pair programming. What else? Oh, continuous integration. Here's a funny thing. Continuous integration is like the only extreme programming practice that really took off, sort of. There are parts of it that many companies are doing, but I think there's still no. It really did sink deeper than anything else, and probably because of CI servers, they became a little easier to grasp for software folks doing software. But everything else, kind of like pair programming, what a waste. I'm charging, I'm paying for 2 programmers to do the job of 1. No, you're not. Do you want to ship software, good software, fast or not? So on my website, I really sort of, it's in a way, its purpose for being is to restore technical Agile practices, particularly for iOS developers, because there are parts of the Agile practices that are hard to grasp until you see them. Now, something like pair programming, I do talk about pairing and mobbing on my site. And if you ever have the chance to take one of my courses or one of my workshops, then you'll immediately see that I'm sort of teaching mob programming on the sly, because it happens to be super useful for a group to develop code together. What an idea. But that's not really my primary focus on my website, because there's not much about that that's iOS specific. That's really more about how do you function together. Refactoring, on the other hand, I think there are elements of this that I really want to get across to an iOS developer audience, particularly because refactoring is another one of those things that's been corrupted in the software industry. People say they're refactoring. In fact, they are just flying blind. Refactoring being following some disciplined steps, usually these. There are others, and there are patterns in how refactoring works that you get accustomed to, so that you don't have to necessarily follow the recipes. But I want to demonstrate refactoring to iOS folks. But in order to do that, you're going to need unit tests. And that's really where things fall down, and that's where, this over here, this book, newly published book, iOS Unit Testing by Example. That's really why I wrote the book. I was originally going to write a book on test-driven development in iOS, but then I realized that the primary obstacle that people faced wasn't TDD. It was that they didn't know how to write unit tests. And this specifically, they didn't know how to unit test most of their iOS code, especially if most of your code happens to be in a view controller or in view controllers. So I set about to write this book that has a view controller centric mentality. I wanted it to be practical for most developers for most code, right? If you're working in an advanced architecture that helps you write testable code, fully for you. Keep going. But that's not most people. Most people are writing, just tossing stuff into view controllers and then saying, there's no way to unit test this. There's UI tests, and so that's what they do. So unit testing is like the key to unlock things for iOS developers. And once you get that, then you can start doing things like refactoring, proper refactoring of moving in super small verified steps with a ratchet, where you're able to ratchet the code to a little better shape, and the ratchet will keep you from slipping back. You take a small step, small step, small step, small step. And test-driven development is definitely has a big sort of heart of it in refactoring. In fact, I would say that is the purpose of TDD, is to empower refactoring. Don't mistake test-driven development for QA. It is not the same thing as what a good tester can do. Good testers, they're evil in a wonderful way. Able to think of and creatively find the gaping holes in our systems and show how where they are weak. Excuse me. I'm going to mute. Oh my gosh. Now I'm a frog. Okay. Let's wrap this up, because now my voice is shot. So, extreme programming, there are other aspects of extreme programming. But the big three that I focus on at Quality Coding are unit testing, test-driven development, and refactoring. And because if you get to see code, if you get to see somebody develop iOS code like that, or take workshops, also come up with classes, online courses at some point, take workshops from me about coding. A question coming in. I'll get to you in a second. Coding, what was I going to say? Oh, workshops to actually experience developing iOS code using the extreme programming principles. Then agility becomes much more feasible. Then your code won't be fighting you, because you can only be as agile as your code lets you be. Excuse me. In the hospital situation, it'd be like if you have poor hygiene, for example, it wouldn't matter how you structured your sort of the operations of the hospital. If you didn't have hygiene, folks would be sick and dying. So this is in a way hygiene for code, and that's why I emphasize it. Let's okay. Hey, Blazing Pear, thanks for chiming in. So what do I think of Mvc Is? Where S is where the service where most of the code goes. There's a misconception that MVC is an application architecture. It is not. It never was. It is a UI architecture. Early Apple documentation, especially early iOS documentation from Apple, incorrectly taught that how do you create your application? Why you use this thing called MVC. And people then ended up coming up with models and views and controllers and deciding that your code needed to be in the model or the view or the controller. This is false, because then we end up with Mvc Is for service, or MVCN for networking, or what are some other variants I've seen? Basically, MVC was only ever supposed to be for UI. The rest of your code is supposed to do what it's supposed to do in an architecture that matches the design needs that you have. So absolutely, I guess the short answer is why yes, Mvc Is. Pull stuff out of your view controllers. But more broadly, continuing with that as sort of the first step, it's like design your code in a way that makes sense. The pattern or the mindset I like to use is to picture my app as if it were on an old terminal. It's like, if this were in a console app, what would it look like, and what sort of interface would I have, and how would I issue commands to it, like typing commands, and what would it do, and what would it spit out? And if I can conceive of the app in this way, then the rest of it, the actual pretty part, goes into the view controller. TDD and pairing are the litmus test of Agile adoption for me. Excellent. That's not a bad litmus test. I think that if folks aren't doing TDD, it's like, well, it's not that they can't be agile, is it? It's that they could be more agile. Same with pairing. And there are other practices that follow the extreme, came after extreme programming, that are part of the whole, still part of the same ethos, namely story slicing. Even the idea of user stories got butchered. User stories have become nothing more than feature lists. That's all. Originally, it was supposed to be just a marker for a conversation that fit on an index card. If it didn't fit on an index card, it was too big. And it was supposed to be so that you could have the conversation with the customer to say, what is this thing supposed to be? And then you can figure it out. And that's it. Alrighty. I've yammered on now for about 45 minutes. Hopefully I can turn some of this into a much shorter video. I'm aiming for 10-15 minute video summarizing my point of view, my manifesto of why I am pushing the technical agile practices in general, and in particular unit testing, test-driven development, and refactoring as the key ways that I like to work, that I think will empower you to ship software in an agile, incremental, constant delivery, incorporating feedback manner, so that you can ship good stuff and sleep at night and have happy customers. And that you would be happy to go back to the code the next day and not go, oh my gosh, I'm afraid to touch that beast because I don't know where it'll break. All right. Thanks for coming by. Thank you for commenting. I appreciate the feedback and the input. Until this becomes a blog post, see ya.